For centuries, astronomers looked at Venus and saw a twin of Earth. It has the same size, the same gravity, and it sits right next door in the warmth of the sun. We dreamed of a world hidden beneath those thick white clouds, a world of oceans, jungles, and perhaps even alien life. But when we finally looked beneath the veil, the dream turned into a nightmare. Instead of a tropical paradise, we found the most hostile environment in the solar system. A planet where the air is toxic, the pressure is crushing, and the surface burns with a heat that never ends. It is a place where our machines melt within minutes, and where life as we know it is impossible. So, what happened to our planetary twin? Why did Earth survive while Venus turned into an inferno? And is this burning world a glimpse of our own future? To understand the tragedy of Venus, we first have to understand just how similar it is to our own home. In planetary science, Earth and Venus are often called sister planets. Venus has 81% of Earth's mass. It has 90% of Earth's gravity. If you could stand on the surface without being instantly incinerated, you would weigh almost exactly what you weigh right now. Both planets have an iron core and a rocky mantle. Both have thick atmospheres and complex weather systems. From a distance, the family resemblance is undeniable. This similarity is why the shock of discovery was so profound. For decades, the thick, white clouds of Venus acted as a mirror, reflecting sunlight and hiding the surface from our telescopes. This mystery allowed our imaginations to run wild. Because the clouds were made of what looked like water vapor, and because the planet is closer to the sun, the logical assumption was that Venus was simply a warmer, wetter Earth. But the reality of the twin paradox is that while the hardware is the same, the software is radically different. Earth developed a system that recycles carbon, maintains liquid water, and regulates temperature. Venus somehow broke its thermostat. While Earth teems with life, Venus is a lesson in extremes. It rotates backward, meaning the sun rises in the west and sets in the east. Its day is longer than its year, and its atmosphere is not a blanket, it is a cage. The divergence of these two siblings is the greatest mystery in the solar system. One became a garden, the other became a gas chamber. We did not learn the truth about Venus by looking through telescopes. We learned it by sacrificing machines, and the nation that paid the highest price to unlock the secrets of the surface was the Soviet Union. While the Americans were focused on the Moon and Mars, the Soviets set their sights on Venus. The Venera program remains one of the greatest engineering achievements in human history. Yet, it is often overlooked. They were not trying to land on a dusty rock in a vacuum. They were trying to land a probe inside a pressure cooker. The early missions failed before they even reached the ground. The atmosphere was so much denser than predicted that the parachutes were torn apart, or the hulls were crushed like soda cans in the upper atmosphere. But the engineers learned. They built tanks. They built spheres of titanium designed to withstand pressures that shouldn't exist on a planetary surface. In 1975, Venera 9 became the first spacecraft to transmit a picture from the surface of another planet. It wasn't Mars, it was Venus. The image was grainy, black and white, and terrifying. It showed a landscape of sharp, broken rocks and no shadows, illuminated by a diffuse, sickly light filtering through the thick clouds. But the triumph was short-lived. The lander survived for only 53 minutes before the heat fried its electronics. The pinnacle of this effort came later with Venera 13 in 1982. It survived for 127 minutes, just over 2 hours. In that short window, it sent back color photos revealing a yellow-orange sky and soil that looked like basalt. It analyzed the rocks and confirmed they were volcanic. It recorded the sound of wind on a dead world. Think about the engineering required for that. To survive just 2 hours, the probe had to be built like a bathyscaphe designed for the bottom of the ocean, yet capable of withstanding temperatures higher than a pizza oven. These robotic martyrs are the only objects humanity has ever placed on the surface of Venus. They sit there today, melted and crushed, monuments to our curiosity and the planet's brutality. What exactly killed those probes? To understand the hostility of Venus, we have to look at the atmosphere. On Earth, the air we breathe is mostly nitrogen and oxygen. It is light, transparent, and life-giving. On Venus, the atmosphere is 96% carbon dioxide. This creates a surface pressure of 93 bars. To experience that kind of pressure on Earth, you would have to dive a kilometer deep into the ocean. If you were to step out of a spaceship on Venus, you wouldn't just be burned, you would be crushed instantly. The air is so thick that it isn't really a gas anymore. It behaves more like a supercritical fluid. You wouldn't walk through it. You would have to push through it, like wading through deep water. Then there is the heat. The average surface temperature is 880 degrees Fahrenheit. That is hot enough to melt lead, tin, and zinc. It is hotter than the surface of Mercury, even though Mercury is much closer to the Sun. Nowhere on the surface is safe. There are no cold poles, no cool nights. The thick atmosphere distributes the heat evenly, creating a global furnace that never cools down. And if the heat and pressure weren't enough, there are the clouds. They are not made of water vapor. They are composed of droplets of concentrated sulfuric acid. It rains acid on Venus, but the surface is so hot that the rain evaporates before it ever touches the ground, creating a cycle of chemical misery called virga. This is not just a harsh environment. It is a sealed system designed to trap energy. It is the result of a physical process that spiraled out of control, a process that scientists call the Runaway Greenhouse Effect. This is where the story turns from a description of a hellscape to a tragedy, because the evidence suggests that Venus was not always like this. Billions of years ago, when the sun was younger and dimmer, Venus likely had oceans. It had a blue sky. It may have had a temperate climate. The data from the Pioneer Venus mission in the 1970s revealed a critical clue in the atmosphere: the ratio of deuterium to hydrogen. Deuterium is a heavy form of hydrogen. When water evaporates into space, the lighter hydrogen escapes easily, but the heavy deuterium stays behind. The high ratio found on Venus is a chemical fingerprint, a ghost of ancient water. It tells us that Venus once had vast amounts of liquid water, perhaps enough to cover the entire planet in a shallow ocean. So, how did a water world become a desert? The culprit was the sun. As our star aged, it gradually became brighter and hotter. Because Venus is closer to the sun than Earth, it reached a tipping point first. As the planet warmed, the oceans began to evaporate. Water vapor is a powerful greenhouse gas, more potent than carbon dioxide. As more water turned to steam, the atmosphere trapped more heat. This caused more evaporation, which trapped even more heat. It was a feedback loop that could not be stopped. Eventually, the oceans boiled away completely. The water vapor rose into the upper atmosphere, where ultraviolet light from the sun broke the molecules apart. The hydrogen escaped into space, lost forever, leaving the oxygen to bind with carbon and sulfur. Without oceans to absorb carbon dioxide, the volcanoes continued to pump gas into the atmosphere, but there was no water to wash it back into the rocks. The carbon built up, layer by layer, century by century, until the atmosphere became the heavy, crushing blanket we see today. The planet didn't just warm up, it suffocated itself. The transformation of Venus is not just a piece of planetary history, it is a warning sign. It reminds us that habitability is not a permanent state. It is a fragile equilibrium. Earth sits in what astronomers call the Goldilocks zone, not too hot, not too cold. But Venus sits on the inner edge of that zone. It shows us that a planet doesn't need to be destroyed by an asteroid or a nuclear war to become uninhabitable. It just needs a change in atmospheric chemistry. For a long time, we looked at Venus as an anomaly. But as we discover more exoplanets orbiting other stars, we are realizing that the Venus scenario might be the default outcome for rocky planets. Keeping a world habitable requires a delicate balance of geology, biology, and atmospheric physics. Venus teaches us that the climate of a planet is a dynamic, powerful beast. Once the balance is tipped, once the feedback loops begin, physics takes over. There is no negotiating with the greenhouse effect. There is no technology that can easily reverse a planetary runaway. We often talk about terraforming Mars, warming it up to make it livable. But Venus presents the opposite challenge. How do you cool down a world that has been boiling for 1 billion years? The rockets are being built to take us to the Moon and Mars. We are looking outward, seeking new homes, but we should not forget the sister world we left behind. Venus is a mirror that shows us a dark reflection of reality. It is a reminder that Earth is an exception, a rare oasis in a universe that is largely indifferent to life. The yellow skies and crushed rocks of our twin planet stand as a silent testament to how quickly a paradise can be lost. We may never walk on the surface of Venus. We may never swim in its ancient lost oceans, but we must study it, if only to ensure that we never let our own home follow in its footsteps. What do you think? Is Venus a lost cause, or should we focus our efforts on trying to tame it? Join us next time as we explore more mysteries of the universe.